So that's not a question for Arav at all. Arav, you have exhausted all your chances to propose anything in the classroom for next 3 months. So I'll talk to you in the month of April. Okay, so on a serious note, so we have already decided what we are going to learn today. We are going to learn how to solve equations, how to solve linear equations. So today we have a new child in the class. Her name is Adandi, and good to have you in the class today. So we are going to learn how do we solve linear equations with variables. So before we do that, what is the ritual that we do in the class on Saturdays? We try doing tables. Yeah. So let's quickly check who knows how much tables. So start with Arav. Table till.
Probably like 12.
Okay, 12 age. No storytelling. Come to the point. 12 age. 12 age. I'll come to you.
Oh, 12 later? Oh, honestly. That's 96. Because I had like some Wi-Fi issues.
Okay. 8 age.
64.
12 7.
84.
9 9.
81.
7 9.
63.
12 9.
108.
7 9.
63.
8 9.
72.
6 6.
36.
12 7.
84.
Good job. Let's go to Anandi. How much of tables you know? You would know. I mean, it's okay. So basically, you know, what I do is, I know kids don't practice tables here. I mean, that's not a norm here, right? So, but I strongly believe that if you know tables, if you're comfortable with tables, it makes your math experience much better. So that's why I ask the kids to spend 5 minutes every day to use the unproductive time to memorize or practice tables, so that when you're doing calculation, you can do much faster calculation that way. So whether you know tables or not, doesn't matter. We'll start from today and let's see how much you know. Table till 10? 12? Wonderful. Let's see. 6 9.
54.
12 8.
96.
6 9.
54.
12 7.
84.
8 9.
72.
Good job. Impressive. 9 9.
81.
Good job. So you know tables. I mean, no question about it, because my goal is to make sure that all the kids in level 2, by the time we finish this school year, everybody should be very well versed, very quick, very accurate with tables till up to 15. And you'll be surprised to know that not even the 10th or 11th graders know the table till 12. Okay. If you guys are knowing it, you're probably, in a different league altogether. All right. So let's go to Dikshita. Table till
13.
13. 6 9.
54.
13 5.
65.
6 8.
48.
12 8.
96.
9 7.
63.
13 8.
104.
Good job. So yeah, I mean, even if you know, you don't know, keep practicing it every day for 5 minutes. Just make use of 5 minutes of your unproductive time and play with that. Okay. And sometimes you can do that in a more playful way. Like you have a sibling, right? So you can say, okay, fine. I have written the tables here. Take this notebook and ask me questions. Let's see how much I remember, how quick I am, how accurate I am, right? So do that in a playful way. You can do some better also. Say, okay, fine. If I get all the questions right in less than half a second, you are not going to bother me for next 5 days. Yeah. All right. So let's bring in that interesting flavor also. Let's go to Thanu. Table till
12.
8 8.
64.
9 5.
45.
11 8.
88.
12 7.
84.
9 9.
81.
8 9 ja.
72.
Good job. Let's go to Advik. Table till
15.
15. Oh, that's it. That's very exciting. Let's say 14 6 ja.
84.
9 9 ja.
81.
14 7 ja.
84.
14 7 ja.
Oh,
90.
119.
No, 14 7 ja is 98.
Um,
So 39 ja.
117.
12 8 ja.
96.
Okay, so I know you are trying to stay ahead of the class, and that is good. I would certainly want you to try that attempt. I mean, keep attempting that. But yeah, you need practice for sure. Okay, so make sure that any table that you claim, it has to be. If I claim that I know table till 16, you ask me any question, my answer should come in less than half a second, without any mistake. If you want to test your teacher, you can do that. Okay, so I mean, I don't preach what I don't practice. So that's what I'm saying. Okay, all right. Vishal,
Yeah.
table till
12.
12 8 ja.
96.
9 9 ja.
81.
6 9 ja.
What?
6 9 ja.
54.
12 8 ja. Sorry, 12 7 ja.
Oh, man. 12 7.
Uh-huh.
84.
9 9 ja.
81.
Good job. Okay, let's go to Myra. Myra, table till
13.
13 13 5 ja.
65.
6 9 ja.
54.
8 8 ja.
64.
13 7 ja.
91.
Okay, so Myra, we have a child here in the classroom. Why don't you come over to the pool table so that Anandi is not alone here? Okay?
Yeah, sure.
Yeah. Okay. All right. Myra is my daughter. So she is hiding in one room, attending a class, being remote. Okay. All right. Let's go to. Yeah. Pranav. Or let's go to Vasundhara then. Vasundhara, table till. Being a notebook also. 12 5 ja. 6 9 ja. Beta, your voice is very feeble actually. I can barely hear you. Yeah. 8 8 ja. 12 7 ja. Good job. All right. Let's go to. I'm being a little forgetful. But okay, let's go to Vivan. I see somebody with name Santosh Kumar. I'm still struggling to figure out the name of the child.
Yeah, my name is Sri.
Sri. Oh, sorry, beta.
Yeah.
Sorry, beta. Yeah. So
I'm used to it.
so try logging with your name next time. Okay, so that I don't have to struggle with my faded memory. Okay. So
It
yeah.
doesn't let me log in with like my name. I can't enter my name for some reason.
Then I have to try to memorize your name, beta. Okay, that's okay.
Yeah, it just doesn't allow.
Oh, okay, that's fine. So let's go to Vivan. Vivan, ready?
Oh, yeah, yes, sir.
Table till
12.
8 9 ja.
72.
12 4 ja.
48.
12 8 ja.
96.
8 7 ja.
56.
12 9 ja.
8. 108.
Good job. Let's go to Sri then. Sri, ready? Sri, ready? Sri, you're on mute still. Okay, in the meantime, I'll go to Pranav. Pranav, are you ready?
Yes, sir.
Okay, table till
4.
8 8 ja,
64.
7 9 ja,
99.
12 5, 7 9 99 49.
No, I thought you said 11 9, sir.
Okay, okay. 7 5 ja,
35.
12 8 ja.
96.
Good job. Okay. Then Sri, are you ready?
Yeah, I'm ready.
Table till
12.
5 9 ja,
45.
12 6 ja,
12 times 72.
8 8 ja,
8 8 are 64. 64.
6 6 ja,
36.
12 9 ja.
And the 108. 108.
Good job. So who's remaining now? Okay. I think everybody is covered except
There's
Gitesh. Gitesh. Gitesh, are you ready?
Yeah, I'm ready.
Table till
12.
12 8 ja,
96.
8 8 ja,
64.
6 9 ja,
54.
12 5 ja,
60.
11 7 ja.
77.
Good job. So yeah, so this is more like a ritual or a jump start that we do on every Saturday, just to make sure that we stay in touch with tables. And we don't do it every weekend, but try to do every alternate Saturday. So and we had a break in between, so fine. We can actually start. So what we want to learn today is how do we solve linear equation with one variable and then linear equation with two variables. Now, who all remembers what do we mean by linear equation?
The equation that helps you draw a line.
Straight line. Yeah. And is there a way you can recognize something as a linear equation without doing any calculation? Yeah, Vishal.
It has to the power of 1 and it goes in y equal mx plus b form.
Okay. So you
Power of 1.
yeah. So basically, you know, what we're trying to say is linear equation, linear. Again, we have learned this before, but I'm just doing a recap. Take one here. Linear equation, if you talk about it, it has a line in it. What it means is a linear equation helps you draw a straight line. And how do you do that? Is that also we have seen in the past. I'll not spend much time doing that. But as Vishal explained, any equation, if I say 3x plus 2y equal to 18, and if I say x squared plus 4y equal to 72, which one is the linear equation among these two? Anandi. Okay, I'll come to you, Arav. Just try to check. You don't know? Okay. Do you know? You don't know as well? Wonderful. Okay, Arav, tell me. Which one is the linear equation among these two?
I think it's the first one because it consists in both variables and it has no square consisting to it.
Yeah. Vishal.
The first one.
Yeah, the first one. First one is a linear equation because by definition, any linear equation is an equation which has two variables x and y and both have maximum power 1. Maximum power 1. If I say is this a linear equation? Yes. It has one variable and the power is 1. If I say 2x minus y equal to 72, is this a linear equation? Yes. Because it has two variables but maximum power is 1. So basically you can generalize that if any equation is there which has one or two variables and maximum power to the variable is 1, that's a linear equation. Yeah? Is everybody with me? Yeah, Advik. You're saying something?
If it has 2, isn't it called a quadratic?
What is that?
If it has like the power of 2, is it called a quadratic?
It's called quadratic equation, yes. So, but we are not talking about that. We are just talking about a linear equation. Yeah. So linear equation by definition, by optics, if you see an equation where it has 1 or 2 variables and the maximum power to the variable is 1, that's a linear equation. That will help you draw a straight line in a coordinate plane. So anybody in the class who's not clear about what is a coordinate plane or how to use coordinate plane, how to use graphs? Have you used graph? No? Okay. Okay. Yeah, Arav?
Does it like have to be like all the quadrants or just the first one?
Hold your question. You are going way too far. Don't go that far. Any other question? I was just saying, anybody not being clear about a coordinate plane. So we just need to be clear about the coordinate plane to be able to proceed further on this one. So we'll just use the basic concept. These are 2 number lines. Number lines you would know, right? Number lines as in 0, 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3, minus 4. Yeah. This is called number line. Yeah. Where you represent numbers. So if you have to represent, let's say 1, this is the point. If you have to represent 2, this is the point. 3, 4, 5, 6. If you have to say 2.5, you know that, okay, it will be somewhere between 2 and 3. Yeah. So it's called a number line. Yeah. So this is one number line, this is another number line which is perpendicular to this one. 1, 2, 3, 4, 5, 6, and here you have minus 1, minus 2, minus 3, minus 4. Yeah. So these are 2 number lines perpendicular to each other. So if you look at this page, this board, if I just say this board, locating any point here versus here versus here, I mean, it's kind of difficult, right? I mean, you need something to refer to. If you, let's say, if you have to locate this place, if you have to drive to this place, what you have to do? You have to say, okay, this is my the origin address, and this is my destination. Then you put that in GPS. It helps you locate. So your address was able to locate that. Okay, this is this much from this place, this much from this place, and you have to go here. So this is this much from this place, this much from this place. So then you are able to find it out. So basically the roads or the maps that you see, every point is located in a certain way by the map. Okay. So the coordinate plane helps you do that. So basically now you can look at this board split by these 2 number lines. And then you can say, okay, fine. This is my 1, 2, 3, 4, 5, 6, minus 1, minus 2, 3, 4. This is 1, 2, 3, 4 this side. This is, and this is called x-axis, this is called y-axis. Okay. So this is called coordinate plane, where you have 2 number lines giving you way to locate different points. So let's say if you talk about this point, you'll say, okay, this is this much far from this place, from this axis, which is called x-axis, and this far from the y-axis. So this point has 2 places called x and y coordinate. So the distance on the x-axis here to here, this is the x coordinate, and here to here, this is the y coordinate. Okay. Am I going too far, too fast? Or you able to follow? You able to follow? Okay. Just stop here. I mean, I don't mind explaining the same thing multiple times. That's okay. Just make sure that you're not assuming anything. Okay. It's okay to ask questions, because there's no question that is a wrong question. Yeah. Provided it's not coming from Arav. Arav asked a lot of questions. Okay. So now every point, let's say if I talk about this point you can recognize, say, okay, fine. This is this far from y-axis, sorry, this far from x-axis, this far from y-axis. So you'll say, okay, fine. This is distance on the x-axis, and this is the distance on the y-axis. So these are called coordinates, x-y coordinates. That's why it's called a plane which helps you recognize the coordinates. It's called coordinate plane. Yeah, that's fine. So now, tomorrow if you have to, let's say, draw a line, what do you need? You need just 2 points and join them. That becomes a line. Yeah. So this coordinate plane helps you locate those 2 points which you would want to join to draw a line. Okay. Now here, what we will do is, we were talking about the linear equation, and I said that linear equation is something that helps you draw a line. Linear equation is not like a printer which will draw a line for you. Yeah, Arav, I said everybody can ask question except Arav, and these are the things that you already know, so I'll not let you ask questions. Hold it for a little bit, okay? Yeah, Dikshita.
Is drawing a line and a slope, is it like the both are same?
Slope is the property of a line. Drawing a line is just connecting 2 points, as simple as that. So once you join the points, so let's say if you're talking about this point and this point, this is very steep. If you're talking about this point and this point, this you see as a little shallow one, right? So the steepness of the line is called the slope. Okay. So, but drawing a line is a very simple task where you're just joining 2 points, that makes a line for you. Yeah. So coming back to the linear equation thing, right? Most of you already know. I'm just trying to make sure that you get an opportunity to do a recap, and some of the kids who have not come across this before, they'll be able to do a recap. I said that any equation like this is a linear equation because both the variables x and y have power 1. So it's a linear equation. But why would you believe me? It has to have some meaning to it. So what we will do is, when you have an equation, for everybody to do a recap, okay? When you have an equation, this is nothing but a contract between x and y, the 2 variables. It says that, okay, we are buddies here, and my value and your value will give me a total value of 7. That's an agreement. Meaning, if the value of x increases, the value of y will decrease so that you get this output. If value of x decreases, then y value will increase to give you total 7. So this is an agreement, this is a deal that you and I will change in a way that our total value is this. So any equation that you look at, that is nothing but a contract between the variables saying, okay, this is what we are agreeing to. If I change my value, you will have to change your value so that this is our output. Okay? Yeah, Raf, if you have a pressing question, I'll let you speak. You have been raising your hand every 2 minutes.
So I actually have a great question. So if that consists of a straight line, what if I had like a different equation that was very different, that was not even a linear equation? What does that change the effective properties of the lines or not?
Today I will give you not my feedback. Let me ask one of the kids in the class. Let's say Vasundhara. Vasundhara, tell me, did you understand the question? I'll put you on the spot today. No, so see again, no intent to make you feel bad, good or bad. I'm just giving you an opportunity that when you're asking a question, you have to think about it. If you know the answer, wonderful. If you don't know the answer, you have to be very clear about what you're wanting to know. So Vasundhara, can you help me understand, can you tell me if you understood the question? But your voice is very feeble, I can barely hear you. Okay, Advik, did you understand?
Yeah, what he meant is like if like we have different variables and will it affect the line?
Different variable, will it affect the line? See, every line, every equation is a unique thing by itself. We don't have to mix 2 things. Let's say this is a line. If I say 4x minus y equal to 72. This is a different equation. This is a different equation. And they may or may not have any relationship among themselves. For the sake of argument, I would say I will always treat them different because these 2 are 2 different equations. So I will not worry about that. I will take one thing at a time, okay, just to make sure that we are staying away from the confusion, okay. This is one equation. If I am dealing with this, I will deal with this. I will solve this equation, deal with it, and then if I have another equation, then I'll look at this guy by itself, and then we'll try to figure out what does it mean what it does on the board. And then if I'm able to correlate anything, then I will try deriving interpretation out of it. But for now, every equation is by itself, nothing to kind of relate to each other. Okay, that's what my response to you would be, Arav, if that was your question. Okay, I will treat every equation separate for now. For me, Biren is Biren, Arav is Arav, Advik is Advik, Myra is Myra, and Anand is Anandi. I will not try to correlate something unless I find a very strong reason for doing so. Okay? Yep. So let's isolate this problem for a little bit, and we'll come back to this. Okay? Now, quickly drawing the graph. Okay? So again, trying to prove something that I have proved before or we have seen before. 2x plus 3y equal to 7. This is my equation. It's a linear equation. I'm forcing you guys to believe that this is draw a line y. Let's do that. So what will I do? As I repeated myself in the beginning, I said that this is a contract between x and y, and they said, okay, fine. I just need 2 points to draw a line. I will just use 2 points, okay? Or maybe 3 points. I'll use 3 points, okay? X and y. This is a contract between x and y in such a way that 2 times the value of x plus 3 times the value of y will give me a 7. Now, if I increase x, y will decrease so that we get total 7. If I decrease x, y will increase so that we get a total of 7. That's the agreement. Okay. It's like in the family, say mom says, I will make only rice and 1 curry today, and we have to make rice and 3 curries today. If I'm making 1 curry, daddy has to make 2. If daddy is making 2 curries, mom has to make 1. Or vice versa. So total there has to be 3 curries, which is the output. Who is making how much? That you have to figure out. That's a deal. Yadvik, you're making curry?
No, that's funny because my dad's making curry right now.
Okay, wonderful. So just after the class you can check with him what is the deal, okay? So is he making 3 curries or 2 curries? That we'll figure out. So here, coming back to this one. So this is a deal. Now, let's say if I put value of x equals to 0, what will happen? What will be the value of y in this case? Any guess, Andy? No? Simple. X is 0. So 2 times 0 is 0. So 3y will be equal to 7. So see, x and y will change in a way that total output is this. So if I'm saying when the value of x is 0, what could be the value of y as per this equation? Are you able to follow me? Yeah, a little difficult. Huh? Little difficult? Yeah, okay. So see, yeah, Advik, you're saying something.
Isn't y like 2.3 something?
Why you have to make it complicated? Tell me. I don't see. As you guys know, I don't really care about the answer. I care about the approach. If you stop at 7 by 3, I would have loved that. Now you'll say 2.33 or maybe 2.34, 2.35. I don't like that. Don't go there, okay? But keep it simple. So I'm just putting a little bit of effort for some of the kids to stay with me. Now this is the equation, okay? This is saying so x is a variable. We don't know what is the value of x. Same is the case with y. So in this equation, this is the agreement that 2 times the value of x plus 3 times the value of y will be equal to 7. Yeah? Fine? So if I put value of x equals to 2, what will it become? 2 times 0 plus 3 times y will be equal to 7. Yeah? So 2 times 0 will be 0 and 3y will be equal to 7. So that means y will be equal to 7 by 3. This is what Advik was telling me, that it will be 2.33 or something. Yeah? This part is okay. So when x is 0, y is 7 by 3, which is little more than 2, less than 3. Is this part clear, beta? Yeah? Okay. Now, what happens when I change the value of x to 1? When x is 1, what happens? What is the value of y then? So it will be 2 times 1 plus 3 times y will be equal to 7. So 3y will be equal to 7 minus 2, 5. or y will be equal to 5 by 3, which is little less than 2. Yeah. So 5 by 3. Yep. So we got 2 points, okay? Let's take one more point. Let's say x equals 2. When x equals 2, what happens? This becomes 2. I'm not looking for any answer from anybody. 2 times 2 is 4. So 3y will be equal to 7 minus 4, or 3y will be equal to 3, so y will be equal to 1. So when x is 2, y is 1. I got 3 values. For x equal to 0, y is 7 by 3. X equals to 1, y is 5 by 3. For x equals to 2, y is 1. As per this equation, as per this contract, as per this deal. Yeah? Yeah? No, and I see. I have a very bad habit of asking it again and again till I get the confidence, till I hear a confident yes from you. Okay, so that's why I'm asking. Okay, that's the main reason. Okay, so now a question to Gitesh. Gitesh, are you able to follow me so far?
Yes, sir.
Okay. So as per this, oops, what did I do? As per this equation, I got 3 values, x and y. 0, y was 7 by 3. When x was 1, y was 5 by 3, I think. And then when x was 2, y was 1. I got x is 0 and y is 7 by 3. When x is 0, so this is 1, 2, 3, 4. 1, 2, 3, 4. When x is 0, so my x will be 0 on this axis, this y-axis. Y is 7 by 3. 7 by 3 will be little more than 2. 1, 2, 3. So it will be somewhere here. This I got as my first point, where x is 0 and y is 7 by 3. Now when x is 1, y is 5 by 3. X is 1, y is 5 by 3. 5 by 3 is little more than 1 but less than 2. Maybe somewhere here. When x is 2, so this is not here, this is kind of here. When x is 2, y is 1. So when x is 2, y is 1. So this point. So if you look at these points, right? Here it is x is 0 and y is 7 by 3, little more than 2. X is 1, y is 5 by 3, little less than 2. And then this point. If you join these 3 points, that makes a line. That's why it's called a linear equation. Okay? So if you have any equation like this, or whatever be the case, what you will do is you will find out the x and y value, and you can assume the values, okay, because every point on this line will satisfy this condition. So you can just pick up any value of x and find out the corresponding value of y, make 2-3 combinations, and then you can plot them. Yes, Dikshita. You're talking on mute. Yeah.
How did you get 1?
How did I get 1? So this was my equation, right? This was my equation. When I put x equals to 2, so that becomes 2 into 2 plus 3y equal to 3. So this is 4. So 4 plus 3y equal to, oh, was it 3 or it was 7, I guess? It was 7, yeah. It was 7, that was my equation before. So 4 plus 3y equal to 7. So 3y equal to 7 minus 4, which is equal to 3. So y equals to 3 by 3, which is 1. Yeah?
Okay, sir.
So simple thing is, when we have any equation, I can create this table and I can plot this line on a graph paper. This is my one way of plotting the line. Now, if I have other equation, let's say 4x minus 3y equal to 8. Again, I'll make a table. I'll put some value of x and y. I'll put some value of x, let's say 0, find out what is the value of y, 1, 2, and that gives me 2, 3 points. Let's say these 2 points, based on these points, I draw this line. I'm just assuming it, okay? So wherever these 2 lines meet, find out the x and y coordinate of that, and that solves that gives you a solution for these 2 equations. So if let's say you have 2 equations like this and this, and somebody says solve it for x and y, you can draw all this graph and solve it. I know I made some very quick statements and to get you all confused. So let's go back into history a little bit. Remember, some time ago I was probably trying to explain you guys that if I have one equation like this where I have x and y are variables, if I have to solve it for x and y, can I get the value by itself? One equation will not be enough. I would need two equations at least. If I have two equations like this, I can solve it. But I just plotted these on the graph paper to say how it will be solved, and probably I will let you guys park this thing for now, okay? Because it might look like an overdose to begin with, but we'll come back to this one, okay? So the takeaway from here is, if I have two equations, two linear equations to solve, what I can do is I can use both the equation to draw lines, and wherever these lines meet, that will be my solution, okay? Just keep that in mind. Wherever these 2 points meet, that will be my solution. The x and y value, the x and y coordinate of the intersecting point will be my solution from these two equations. But hold it there. It might sound little cryptic right now. Just park it there, okay? I'll come back to this one after we solve few more things. Now let's go back to algebra, because coordinate planes might have gotten you a little loaded, and let's come back to some interesting stuff. If let's say if I say 4x equal to 16, can you tell me the value of x? Yeah, yes or no?
4.
4. This is easy peasy, right? Everybody loves that. Yeah. If I say 4x plus 3 equals 11, tell me the value of x. Who can tell me? Andy, you can try to tell me. No? This is a simple equation. Yeah.
The value of x is 4.
Value of x is 4. Why?
Because you need to
No,
find out what
you rushed out for the answer. Solve it, then tell me. Yeah. Yes. Value of x. So 4x plus 3 equal to 11. So I'm saying what is the value of x? Let's see what Dikshita has to say. Dikshita, unmute yourself. What is that?
2.
Okay. 2, yeah. Yeah. Ashrit, what is your answer?
2.
2. Gitesh also 2.
Yep.
Vishal also 2. Okay. That is too much. Okay, that's a bad joke. But again, why so? Simple thing. 4x plus 3 equals to 11. So what we want to do is, we want to keep x on one side. We want to come to a point where we say, okay, x equal to something. That's what we are trying to come to, right? Now, that means we want to kick everybody out from this side. Knock off 3. So if this 3 moves this side, what it becomes? 11. Plus becomes minus. Minus becomes plus. Multiplication becomes division. Division becomes multiplication, right? That's what happens when you make anything cross the equal to sign. So here it is plus. So if you make it travel to that side, it becomes minus 3. It was plus 3 here. You moved it that side. It became minus 3. So that is how 4x equals 11 minus 3 is 8. This part is clear? Yeah? Now, so 4x equals 8. So x equals 8 divided by 4. Like I said, whatever is the sign here, that becomes the opposite. Plus becomes minus, minus becomes plus, multiplication becomes division. Here it is 4 times x. So it will become division here. So 8 divided by 4. That is how you get x equals 2. Yeah? Clear? But I'm not here to tell you guys that how to solve these kind of equations. That was not the intent. The message was different. Now look at another thing. 14x minus 32 equals 10. Same thing you will do. You'll make this guy to this side. So 14x becomes 10 plus 32. So 14x equals 42, or x will be equal to 42 divided by 14, which will be 3. Yep. Now, again, as I said, I'm a mischievous teacher. I'm trying to convey something different here. Look at this equation, and this equation. What do you see? There's only one variable in all the three equations. When you have one equation with one variable, you are able to find the answer very quickly. Only one variable x in this equation. Only one variable in this equation. You're able to solve it. Even if I say 2x plus 3x equals 15, solve it for x. You can still solve it. 2x plus 3x will be 5x, will be 15. So 5x will be equal to 15. So x equal to 15 by 5, which is 3. So you saw another thing here. What is the similarity between all these four equations? This one has one variable, this one also has one variable, this one also has one variable, this one also has one variable only, because even if these are two different terms, but variable is only one x. So the takeaway from this is, any equation, if you have one equation with one variable, it's very easy to solve. You can solve it. Okay, you can get the value of the variable. Now, if I say solve it, find out the value of x and y.
That is not possible.
Not possible. Why?
Because see, there's two variables. So if it's a linear equation, two variables should actually have two equations for each, because one of the variables needs to be substituted.
Stop there. Don't take away my job. Okay, that is my job. So right now what I'm trying to tell here is, and which is pretty much in line with what you said, but you went little too far, which I was not wanting you to. If I have one variable in an equation, I can solve it and find out the value of the variable. If I have two variables in an equation, I cannot solve it. It just gives me different possible values of x and y. That is what we did a little while ago. Remember? It just gives me different values of possible values of x and y. By putting value of x equal to 0, I got something. Putting another value of x, I got some other y. Putting another value of x, I got some other y. So this gives you a possible range of combinations that, or solutions that you can get. Or if you relate that with what drama I was doing on the screen was, when I was plotting this line, every point on this line is the x and y value, which could be a solution for satisfying this condition. So a linear equation by itself doesn't give you any answer. It gives you all possible combination of x and y values that you can have. Okay? Now, like what RF said, if you have to solve for two variables, you need two equations. When you have two equations and two variables, then you can solve it. How is what we are going to learn. Okay? So Arav, I think, knows. He mentioned about substitution. Many of you would be knowing about it. So there are two techniques. One is called substitution method, and one is called elimination method. Myra, don't be busy taking notes. You have everything recorded here for you. Okay? So that's what I prescribe you guys not to be busy taking notes, because what happens is when you are scribbling while I'm teaching, some of the concepts you might not focus on. So that's why we have the video. Okay? So when you have two variables to find out the value for in the form of an equation, you need two equations for sure. Whether this equation or some other equation, doesn't matter, but you certainly need two equations. And when you have two equations, two linear equations, then only you can try attempting to solve it. And there are two methods of doing it. One is called method of substitution, one is called method of elimination. Ultimately, it again goes back to what I was saying 5 minutes ago. What you are trying to do, you know that if you have one equation with one variable, you can find out the value of the variable. So when you have two equations like this, ultimately you will do all kind of manipulations with these equations to build a new equation which will have only one variable. Now, whatever I said, that might be sounding a little cryptic to you guys, but let me actually do it. Let's say I have these two equations. Let's pick up this equation here. From this, what will be the value of y if I take it here? Y will be equal to 18 minus 3x. I can say that, so, right? I just made this guy move to this side of equal to. So this is plus 3x, so this became minus 3x. So I got a value of y. What I will do is, I will substitute the value of y here in this part, in the first equation. So I will say 4x plus 2 times the y equals 15. So what did I do? I took the value of one variable from this equation and I substituted that value in the first equation. That's why this is called method of substitution. What did it do for us? Now you look at this. You only have x here. You don't have any y. So you have one equation with one variable. That will help us find out the value of x. And once we find the value of x, we can put here, we will be able to get the value of y. Let's look at it. So this is 4x plus 2 times 18 is 36 minus 2 times 3 is 6 minus 6x equals 15. So you got 4x minus 6x, which is minus 2x plus 36 equals 15, or minus 2x equals, this also goes this side, so 15, and this 36 becomes minus this. So minus 2x equals 15 minus 36, that will be minus 21. So x will be equal to minus 21 by minus 2, which is as good as 21 by 2, which is 10.5 or whatever you call it. And now you can put this value of x in this equation or this equation and you'll get the corresponding value of y. So when you had two equations, we use this method of substitution to find out the value of x, and then I can use the same value of x in one of the equation, which will get me the value of y also. Now let's do this way. Let's go here. So value of x I got as 21 by 2. So 3 times x plus y equals 18. So 21 times 3, 63 by 2 is 31.5 plus y equals 18. So y equals 18 minus 31.5, which is minus 13.5. So you got x equals 10.5 and y equals minus 13.5. So what happened here? A summary of this is, you had two equations, you picked up one equation, one of the equation, and found the value of one of the variable in terms of the other variable, and used that value like this in this equation so that you get rid of y completely. And that helps you convert this into an equation, one equation with one variable. One equation with one variable, you can find the answer for that variable. And once you have the value of the variable, you can find the corresponding value of y. Yes, Dikshita, you have a question.
How did you get negative 2x in the substitution method?
So let's do it one more time. Math is about not getting tired. Let's do it one more time. So I don't know whether you guys get tired or not, but I don't. When I'm doing maths, I can do the same math 100 times if you want me to. I mean, I know that's not very exciting, but that's how it has to be. So here, what did I do here is, okay, the y, here I have y as separate. I can take y out from this equation. Find out the value of y here. What will that be? Meaning I will have to move this guy to the other side. That means if I keep only y this side, then this guy moves to this side. So this becomes 18 minus 3x. Up to this much is okay? Yeah? Okay. Who's not okay? Okay. All right. So from this equation we found the value of y in terms of x. Now take this value of y and put in the other equation. So my other equation is 4x plus 2y equal to 15. 4x plus 2y. Y is nothing but this value. 18 minus 3x. 3x equals 15. So I'm just breaking the bracket open. 4x plus 2 times 18, 36, plus 2 into minus 3x. So plus 2 into minus 3 plus into minus will become minus. 2 into 3 is 6x equals 15. So now 4x plus 4x minus 6x will be what? You have 4 credit, this much. This year earning, this year spending. So you have total this much spending. 4 bananas minus 6 bananas minus 2 bananas plus 36 equals 15. So minus 2x equals, this guy also goes to this side if you want to isolate x. So it becomes 15 minus 36. So minus 2x equals minus 15 minus 36 will be minus 21. Now is this clear, Dikshita?
Yes, sir.
Okay. Anybody who is not clear? Ashrit, Sri, Advik, Tanu, anybody? No? Vishal? Okay.
It is the Ohio Skibidi, yes.
That is what calls for a moment of silence. I'll not react to things which are not relevant to me or relevant to us in the group. Yeah? All right. And I don't know how your teachers react in the school, but these kind of things nobody likes. Sooner you learn it, better it is. Okay? Now, stop playing with emojis, focus here. So what we did was, this is called method of substitution. And that's what I want to kind of enforce here in this class. That what we are doing is, we have two equations. First thing is, if I have to solve for two variables, I need two equations, no doubt about it. And our ultimate goal is to get to a point where I have one equation with one variable. That is what we are trying to get to. And this is the method of substitution which helps us, where we find out the value of one variable in terms of the other variable and substitute it in the first equation. And then you can choose here also. You can pick this one, 2y equals to this. So y will be 15 minus 4x divided by 2, and you can substitute that value here. I mean, any which way that works for you is fine. There is no rule that you have to go certain way. You can pick one equation, from that find out the value of one variable in relation to the other variable and substitute in the other one. Whichever you find easy, you can choose. There's no rule, no guiding principle as such. Yeah, Nitesh, you had raised your hand. No questions? Okay. Alright, so this is called method of substitution. There is another method which is called method of elimination that we will learn in the next class, which will not be tomorrow, because tomorrow we are doing test, and test will be fun. Because see, the difference of between this test and any other test that you guys would have given, you guys give test to get your score. This test is for you to give, but to get my score. Meaning, I'm trying to figure out how effectively I have taught the concepts. When you guys answer the questions, right, that will give me an indication of what all you have understood, where I have explained things better, where I have not. And that is what we'll focus on in the coming classes. So it is an assessment of how effective my teaching is rather than you guys getting any score for that matter. Yep, yeah, Dikshita.
How many questions are there?
Probably 15 to 20. I'm still working on that. Yes, Sri.
Does everyone have to do it? Like even the new kids?
Yeah, so in fact, no, that is a very good question, and I would say it is, because when you guys give the test, right, even if you have not attended the classes, at least that will give me an indication of what are the topics that is clear to you and which are the ones that is not. Because
Like our capabilities, like you get to know our capabilities.
not I would not use capability because that's not the right word. It's about what you already know and what you're comfortable with, right? So any concept that you're not comfortable with, that is what my intent is. I'm just trying to understand that so that I can put more emphasis and focus on those topics to make it much more easier, comfortable for you guys.
Wait, what score is mastery? Like, is 80% above mastery? Is like 90% above mastery? Like,
So as I said, this is not your mastery, this is my mastery, right? So I'm trying to assess how effectively I have been able to explain things to you guys, right? So whenever I see you guys making when I see a certain trend, that will give me an indication of what are the topics where I have not done a good job as a teacher, right? Or you have not got a chance to learn those. So that is why, I mean, this test is not to scare anybody for that matter, okay? This is only for me to understand where I have to put more energy to make things much more comfortable and easy for you guys. Yeah?
yeah.
Yeah, Dikshita.
What are the topics?
I have sent that in the WhatsApp group. I would not remember that. I have sent out a list of topics that we are going to have questions on. I would not remember it right now, but yeah, it's there in the WhatsApp. You can check with Daddy. Yeah. Yes, Advik.
So what if we're coming to the room for the test?
So I would suggest not to come to the room for the test. The reason being it's very bad weather right now. So you can still do it at home. My only thing is I expect you all to be honest, okay? Because again, I'm not assessing you, right? There's no score that is going to go to your parents or to make you feel good or bad. It is just a reflection of how my teaching has been, how effective it has been for you guys. So I'm just trying to get a sense of that so that I can put my energy in the right places. So just do a good job, put an honest attempt, and that should be good enough for me to get some indicative view of what I should be focusing on for you guys. Yeah? Yeah, Dikshita.
Sorry, say I was a mistake.
Okay, all right. So that being said, we are top the hour. I will let you guys go and see you at 3:30 during the test. Hope you guys enjoy that. And that test is, again, as I mentioned, this is not to scare anybody. So take it with a cool head and focus more on concepts rather than rushing for completing or doing anything. I mean, I just need some indicative view of what are the things that is not clear to you guys. Okay? Yeah, everyone.
Okay, I have to look like that.
That's okay. All right. So enjoy the rest of your evening. Yep.
Should
Yep.
we join the class at 3:30?